Hi everyone. Thanks so much, Anna and Michael, for the opportunity to talk here today. So my name is Eric Lopatin, and I'm the Digital Preservation Services Manager at the California Digital Library. CDL is part of the University of California system. It's a centralized resource. We provide a lot of different either platforms or solutions to all the different libraries that are at the 10 University of California campuses. Our particular group is the UC Curation Center, where we work on digital preservation, data management plans, persistent identifiers, and data curation and publishing. So this talk is titled Implementing an Ingest Workspace using a series of different cloud technologies. Our particular preservation repository is all cloud-based, meaning that all of our copies are in the cloud across 3 different service provider or storage providers. So we were in a position to build or just actually had the need to build a workspace that was also in the cloud in order to help out a variety of library partners. Okay, so the definition of the problem that we were facing essentially is across the different UC campuses. There are many libraries, affiliate libraries, memory organizations. They're interested in starting up digital preservation projects, and that interest has increased over the past few years, which is wonderful to see. But many of them have very limited resources to apply toward archiving their content in a digital preservation repository. So although they have obviously control over the catalog and any of their content or physical archives, they also have control over the associated metadata in the catalog, et cetera. A lot of them tend to work with vendors or other larger library units to acquire digitization services. So for example, I was recently working with a group at Berkeley, and they've been actually going through a digitization process for manuscripts over the past year. And they're kind of contracting that out and have established an entire workflow on their own. But that results in digitized content that's typically relayed to CDL on hard drives or other portable media, or even copied to an S3 bucket. And then we need to work with them from that point forward to create submission information packages and eventually ingest those packages into the preservation repository. And I saw a question come up in the chat really quickly. Okay, thanks. Just wanted to make sure I didn't miss anything. So to provide some additional context here and then requirements for the solution, so we really wanted to enable acquisition from these devices or storage areas or networked area storage in different places essentially across the campuses. But to have a space to work on this, a central location to prepare and stage the content for ingest, we came up with a few different ideas that we ended up talking to our internal IT about, including having a dedicated workstation, possibly even using individuals' laptops or other network resources. So understandably, they kind of pushed back on this because of the costs and the maintenance that was going to be incurred in the long run. So we also, one of the other main requirements here is that whatever workspace we set up had to be completely accessible to the repository's ingest microservice. And then we also had this life cycle in mind where in order to make sure the costs weren't going to go out of control or anything like that, because we're potentially storing a lot of data in S3 at any given time. We wanted an environment that we could easily spin up, and then when the project was done, we would just tear that back down until the next project came along. That made it more economically feasible overall. So the solution that we ended up coming up with is this S3-based workspace. And it essentially serves as a bridge between a Linux environment, like a shell running on a cloud-based server, an EC2 instance, in other words, and an S3 bucket. Users are able to push the content to S3, interact with the files via the shell, and incorporate metadata into the batch submissions that they create automatically. On submission, the content is pulled from S3 and then combined with the metadata via manifest files, which is a file format our repository uses to define high level, like object level metadata. We have several fields that we recommend people provide metadata for each of their objects. And then all of that is combined essentially with the files and ingested into the repository. So just a couple of visuals here to kind of just reference what's happening. Initially, when you get into this entire workspace, the first thing you're going to want to do is authenticate to AWS, and it's something that we have a lot of services that require this authentication. We try to share that authentication across those services. But the AWS has a systems manager, and we have a console. We essentially just log in there. And then we have access to a bunch of different resources. In this case, I'm connecting a hard drive to my laptop after I've authenticated, and then I'm essentially using the AWS command line interface to push up files to the S3 bucket directly, or if I want to open up any kind of development environment that can accommodate with this kind of SSH access, which is obviously super common. I'm able to actually drag and drop files from my desktop like all the way up and have it copied to the S3 bucket automatically in the background. So it's really trying to kind of remove a lot of the challenges along the way and just enable any user to work in a shell and, let's say you have scripts that you're going to automate certain processes for staging with, whether that means, creating checksums or organizing the files in certain folders, working with the metadata, all that sort of thing can all be scripted if you want to within this environment. So the second part of this workflow here, once everything's up in S3, I have a few steps. The EC2 is where I log into via SSH. So that's the cloud, the host up in the cloud that, in our case, is up in Oregon. But then there's this great element in between here, which is actually was the thing that we discovered to make this all happen is Amazon's file system, or FSX for Lustre. And what Lustre does is it essentially, you copy your files to the Lustre file system, and then it takes care of syncing everything up to the S3 bucket transparently. So you don't really have to think about moving things, copying things. The AWS command line interface for S3 is much different in terms of commands than any kind of typical Bash shell or ZSH shell or anything like that. The underlying resources, as you can imagine, there are a bunch of things that are driving this in the background. But like I said, we wanted to spin this whole environment up very easily and then bring it back down according to the project lifecycle. So there's a whole set of configuration management that's happening in the background. We actually used open source software called Scepter that's out there on GitHub, and it drives. It's essentially like its infrastructure as code, which is actually what CloudFormation is, another AWS option. But it drives CloudFormation, so you can essentially automatically set up your permissions and your security elements, automatically set up that EC2 host in the cloud, automatically set up the S3 bucket and all those elements and the Lustre file system together. Really, what this takes now that it's set up in Scepter is we run one command, and Scepter drives all that creation, and within about 10 minutes, the workspace is available. It's really amazing. And many thanks to our development team, especially just getting into all of this and making this happen over the past bunch of months. The other major element here is an AWS Lambda function. And so that Lambda function is running whenever we need it to run. It will list the contents of the S3 bucket on a web page for us. It will generate the links to all that content in S3. So when the repository needs to pull it, that link is a pre-signed URL essentially. So it's a very secure transfer, time limited, that comes across from the S3 bucket to the repository. And then an application load balancer and the Lambda, like I said, they give us access to a web page, which I'll show you shortly, that lists everything that's in the workspace. And then, of course, the Lambda also enables merging the metadata from with the actual images and other archival content that you're assembling for a submission information package or a SIP. So okay, let's go ahead and jump out of the presentation, and I will come back to this. And let's take a look at how all this stuff works. It's a little bit of a deep dive for the next 10 minutes or so. But what I have is a series of a very small set of image files, both Access, JPEGs, and TIFF. I'm just going to combine everything for the purpose of the demonstration. But here I am on my laptop, and this is a directory where I have the demo files for the webinar here. I'm just going to list everything here, and you can see I have 6 different files and then a proprietary image file format there as well. In this case from a phone. And what I want to do is I want to find out what's up in the particular bucket that I'm working in. So this is a very straightforward S3 command here from the command line interface. And this is my demo folder. And really right now, there's absolutely nothing in that demo folder that we can see. So I want to push these images up to it. So I'm just going to go ahead and use a cached function here. So I'm going to copy everything up to recursively up to the S3 bucket. And I'll go ahead and copy that. So I'm just basically uploading these files to the S3 bucket right now. It's going a little slower than usual. Sometimes if I'm working at the office, this is a very quick upload. So it's like 24 megabytes a second kind of thing. So in the past project that I was working with this workspace with, we had 50,000 files to upload to the workspace. And that actually went pretty quickly on a drive-by-drive basis. I got many files uploaded during the course of, a couple days at the office on and off. So, okay, the files are up there. Let's go ahead and list the contents of the bucket, or that folder in the bucket again, and you can see everything is up there, including this DS store file and an Apple file that I don't really want. So this is just an initial, let's get the files up to that bucket. This is not really where I prefer to work. What I'd rather work in is a development environment like VS Code. So I'm going to go ahead and open VS Code here. And it's actually connecting to the same cloud-based instance or host. And it's also listing the demo files that I just uploaded. So what's actually happening in the background is I uploaded those files to the host. And on that host, there's a volume that is being provided by the Lustre file system that I had mentioned earlier. Then in the background, Lustre is now copying all of that to S3. And if anything happens here within my workspace, it will mirror that action on S3 for me. I don't have to really think about it. Again, let's just find out where I am, and let's list all these. Let's go to the ingest workspace and the demo folder, and there are my files. So at this point, if I really want to, and it takes a little while because this is VS Code and it's not really made for this, I can preview my JPEGs if I really want to. I can also install extensions for previewing the TIFFs or anything like that. So this is going to come up with an image in a sec, and you can see that you can zoom in. These images are from a trip to Scotland in 2022, which was absolutely wonderful in the Highlands. But let's go to the website representation of the workspace. Now, this is the Lambda that is showing us this listing. And I'm going to refresh the page here, and you can see here are my files once again. And then there's some other information here that we're going to chat about in a second. But let's actually get rid of that DS store file first. And oops, here we go. So I'm going to make this a little, hopefully everybody can see this. If it's not large enough, please holler via the chat. I'm going to go ahead and list all of the invisible files as well. And then I'm going to, here's a DS store file. I'm going to remove the DS store file, and that's eventually going to be removed from VS3 bucket as well. And then just so you can see how it's very easy to remove any of these files, I don't want this proprietary format either. I can just choose to delete it. And then VS Code will interact with everything in the background and eventually just go ahead and delete this file. Okay, so what I want to do next is actually combine some metadata with my image files here. And if I refresh, you'll see that proprietary image format is gone. The workspace gives me this CSV file that I can actually download and enter my metadata into. So I'm going to go ahead and save this link. I'm going to name it merit.metadata.csv. Yes, let's use CSV, and then everybody's, let's go ahead and open this into, it's yet another spreadsheet, CSV, open it in Excel. So typically what happens at this point is I will end up with a lot of metadata from the metadata librarian that I'm working with on the project, instead of like literally typing in everything here, which is I'm going to do for the purpose of the demo. You can see here's a local identifier field. These are the 4 fields that we really want people to fill out. And now just for simplicity purposes, I'm going to add some titles here. This is Glencoe Hillside and access, and then we'll do this again, but we want the actual high-res image, and then let's go ahead and do a couple more things. I know this particular, these are wildflowers, and this is the high-res. And then, oops. We also have a panoramic vision or image. Access. And also the high res. So bear with me as I go ahead and type all this stuff up here. And then we can put in my last name and just go ahead and add that as the user. The reason I'm doing this is really because I would like to go ahead and ingest all of this into our preservation repository and show you the results of it. So I want to make sure I can, okay, I'm just going to accept those years. Let's save this file and then quit out of Excel. And what I want to do is literally show that drag and drop functionality. So here's my metadata file. I'm just going to drag it and drop it. It's going to be uploaded by VS Code, and I can see my CSV file right here. But because I named it merit.metadata, that's kind of a magic file name. If I go back to the web representation, when I take a look at the actual manifest file now, which is a little text file that we use to ingest our content into the repository, you can see all the metadata has been added according to each object that's going to be ingested. So each one of these lines is going to create a new object in the repository. So let's go ahead and do that. I'm going to go and download this particular file. And batch objects dot checkm. This is our internal file format. And let's go ahead and submit that to the repository. So I've got our Merit repository. Merit's the name of our repository, and it's been running since about 2012. Let me make this a little bit bigger. And I will go, this is our demo collection, and I'm going to go ahead and add an object, or actually in this case, multiple objects to the collection. And you can see I've already kind of tested this out in the background. So if this takes too long, we can go back and look at some of the other objects. And here is the submission manifest, and I'm going to go ahead and submit it. So what this is going to what's going to happen in the background now is the Lambda is going to provide the pre-signed URLs to the Merit repository, its ingest service. It's going to pull down. It's going to pull all the images one at a time, merge it with the metadata that we just saw, and create new objects in the collection. So this takes a little bit, as you can imagine, but while we're waiting, we can also just take a look at the individual objects that are already in the collection itself. Give it a second here and hope that the demo doesn't go sideways. It's gone okay so far. Yes, definitely a dangerous game. Okay, we're back. Okay, so these are some of the other images that the other objects that I ingested earlier today. Let's just take a look at one of them so we can, for the sake of seeing the metadata, and clearly I was in a hurry and reversed some fields here. So this should be the title, this should be the creator, this should be the date, and then I can add a local identifier. But then again, this is the image that's in the repository right now. It's the JPEG access copy of it. And then as we're sitting here, you'll see additional objects kind of come into the repository, and then another image that we had. So okay, that pretty much concludes the demo. Let me go ahead and hide all this stuff. And yeah, like I said, this has been a really exciting project for us. It took us a few months to put together, but we'd be super interested to hear from you if you've done something similar. This is a use case that applies to a lot of different libraries across the UC campuses that have limited resources, and it's been wonderful to be able to help them out as they digitize the content or work with a vendor. Then we work with them with the metadata and getting everything over to the repository and creating the object structure and the SIPs and everything and putting everything together. So yeah, that pretty much wraps up my presentation. Thanks so much.